What the declassified pages show. The declassification didn't come in one dramatic release. It came as a slow leak, fragments uploaded to the CIA's digital reading room between 2013 and 2002, scattered among unrelated files. Most people ignored them at first. Then someone noticed the title buried in the metadata, The Adam and Eve Story. For decades that phrase had lived only in rumor, whispered among fringe historians and survivalist circles. Now at last, the missing pages were visible, or at least parts of them. The content was stranger than anyone expected. Thomas's prose read like a scientist trying to describe an apocalypse in lab language. He outlined a planetary mechanism of rebalancing, a cycle repeating roughly every 6,500 years. In each round, as he told it, ice accumulation at the poles destabilizes Earth's rotation. When critical stress builds, the entire outer crust shifts around the molten core, realigning the continents in new positions. Oceans rush violently across the surface, erasing civilizations in hours. Then the poles refreeze, and humanity begins again. It wasn't just cataclysm, it was rhythm. Thomas described history as a heartbeat of destruction and renewal. He cataloged 6 previous cycles, assigning each to mythic accounts: Atlantis, the biblical flood, the fall of ancient Asian kingdoms. In his view, these weren't allegories, they were geological log entries recorded in religion. Every few thousand years, the planet hit reset. To mainstream science, it was nonsense. Physical crust displacement on that scale would require unimaginable energy. Yet the imagery felt vivid enough that even skeptics couldn't forget it. And buried among the metaphors were pieces that sounded disturbingly specific. Tables labeled magnetic transition interval. Coordinates marked current equatorial tension. Diagrams showing water engulfing what looked like the eastern seaboard of North America. Readers quickly began stitching the fragments together. On online forums, digital archivists compared Thomas's coordinates to modern coastlines. When geospatial software overlaid those lines on actual topographic maps, the results went viral. The projected flooding zones looked similar, uncannily so, to FEMA's high-risk flood boundaries and climate migration simulations drawn half a century later. That resemblance didn't prove anything, but it didn't need to. Coincidences this visual practically advertised themselves. One detail especially electrified researchers: Thomas's approximate timing. He claimed the last crustal shift ended 11,500 years ago, the same period geologists associate with the Younger Dryas, a global temperature crash that coincided with mass extinctions and bursts of meltwater flooding into the oceans. Scientists attribute that event to complex climate feedbacks. Thomas saw it as evidence of total planetary reorientation. The overlap was enough to reopen a door the CIA had never properly closed. As the declassified pages circulated, readers noticed tone shifts. Early chapters sounded quasi-scientific, filled with equations about centrifugal force. Later ones read like scripture. "The sun will rise again on a new equator," he wrote, "and survivors will remember the fire as the voice of God." That blend of cosmology and mysticism explained why the agency might have treated the book carefully. It was the sort of narrative that could blur science and prophecy in the public mind. But fascination rarely needs full proof. People wanted to believe the government knew more. Independent document restorers began applying image enhancement tools to the scans, revealing faint ghost text under the black blocks. Some claimed to read names of locations: Denver Basin, Tibetan Plateau, Pacific Compression Zone. Others argued those were artifacts of aging paper. To believers, though, these traces looked like a hidden atlas, places predicted to survive. Once those whispers took hold, a second wave of theorizing began. If the book was classified because it predicted real geological change, then the Pentagon must have used it as an internal reference. Suddenly, the 2018 leaked map labeled Geophysical Transition Zones wasn't just coincidence, it was continuity. Online sleuths overlaid Thomas's surviving world diagram onto the leaked image. The alignment of red-shaded regions astonished them. The same continental fragments, almost the same latitudes. Whether the resemblance came from creative speculation or deliberate modeling didn't matter. The visual story wrote itself. Document analysts pushed back hard. They pointed out that Thomas described instantaneous crustal displacement, while current geophysics only acknowledges magnetic reversals, slow, invisible, unfolding over millennia. His model ignored tectonic plates entirely. But outside the academic bubble, those distinctions blurred. When the magnetic poles drift faster every year, When satellite data show weakening field strength, the math of fear feels simple. Something's moving, and maybe he'd guess the pattern first. The allure of the declassified pages is emotional as much as intellectual. They confirm that the question was once taken seriously by people in power. Even if the CIA only filed the book away out of bureaucratic habit, the very act of storage feels like agreement. Add to that the modern climate of uncertainty, rising seas, strange weather, government mistrust, and you have the perfect conditions for resurrection. Scroll through the surviving scans and one thing becomes clear. Thomas didn't just invent mythology, he curated it. He referenced over 100 flood legends from around the world, connecting each to specific continental regions. Mesopotamia, China, the Andes, different stories, same destruction. He called this the cycle of forgetfulness, claiming every civilization erases its predecessor's memory through disaster. In a subtle way, his book wasn't about geology at all. It was about amnesia, the recurring loss of knowledge after collapse. That theme resonated far beyond scientific debate. By the time modern readers rediscovered those pages, the text had transformed from pseudoscience into allegory for conspiracy itself. The redactions symbolize the portion of truth always kept out of reach. When you stare at them, you don't see censorship, you see promise, that behind every black bar lies confirmation of our suspicions. It's irresistible psychology, the very engine of 21st century paranoia. Yet there's another layer worth noticing. Hidden between the bold claims are brief, almost technical footnotes referring to geomagnetic reversal precursors. That term reappears later in legitimate scientific papers to describe magnetic field weakening before reversals. Whether coincidence or prescience, details like that lend an eerie echo of accuracy to fiction. Enough to make strategists curious, perhaps cautious. Enough to justify a quiet look, at least during the Cold War, when information alone could shift policy. So the declassified pages tell two stories at once. One is John Thomas's, the myth of repeating cataclysm dressed as science. The other is ours, the modern attempt to read warning into every omission. Somewhere between those two lies the reason his work refuses to die. Half a century after its suppression, the release didn't settle anything. It accelerated everything. Searches for crustal displacement tripled. Copies of the PDF were downloaded millions of times. And in the background, magnetic field readings showed measurable decline, the real kind scientists tracked daily. Fiction and fact had synchronized by accident. When the last missing chapters finally reached public databases, analysts noted a final passage quoting a line from Ecclesiastes. There is no new thing under the sun. For followers, that wasn't philosophy, it was physics. The planet had done this before, it would do it again. But what does actual evidence say about that claim? Is there any sign in real data that our magnetic field might be heading toward instability powerful enough to echo Thomas's predictions? To answer that, we have to leave speculation behind and step into modern geophysics, the arena where myth collides with measurable truth. The line between catastrophe and natural evolution sits there, buried in the core of the planet itself. Real science of magnetic reversal. Let's set superstition aside for a moment and ground the story in what we actually know. Earth's magnetic field isn't static, it flips. Sometimes slowly, sometimes unpredictably, but always by the same invisible engine churning in the planet's core. Liquid iron moving around the solid inner core creates a self-sustaining geodynamo, and every so often, that engine sputters and rewires itself. When it does, north becomes south and compasses would spin the wrong way, if humans had existed to see most of them happen. Over the last 160 million years, this reversal has repeated hundreds of times. The geological record preserves each one. Lava flows cool, minerals inside lock to the magnetic direction of that era, and later layers point the other way. It's like tree rings of polarity, bands of north and south alternating through stone. The last major flip in that pattern is known as the Bruns Machiyama reversal. It happened roughly 786,000 years ago, confirmed by analysis of volcanic deposits in Hawaii, Italy, and the Atlantic seafloor. For most of history, scientists thought transitions like that took thousands of years. Then new data arrived suggesting one shift may have finished in less than a century, shockingly fast on a geological clock, but still gentle compared to anything in John Thomas's imagination. A related but smaller event, the Lost Champs excursion about 42,000 years ago, adds the fine print. It wasn't a full swap. The field briefly collapsed to a fraction of its usual strength. Magnetic north wandered almost to Antarctica, then bounced back. During that interval, cosmic ray bombardment increased, ozone thinned, and some environmental disruptions appeared in the climate record. So while reversals aren't world-ending, the weakening phases around them can influence atmospheric chemistry and radiation exposure. For ancient humans navigating under the aurora, the sky would have glowed in places it never had before. Today, scientists are watching something that feels eerily familiar. The magnetic field's overall intensity is declining about 10 times faster than its long-term average. Over the South Atlantic, near Brazil, lies a patch of especially weak magnetism called the South Atlantic Anomaly. Satellites passing through it glitch from radiation bursts. The International Space Station routinely powers down instruments when it drifts overhead. This anomaly has doubled in size in the last 2 centuries, and nobody's quite sure why. That uncertainty fuels speculation. Are we witnessing the early tremor of a new reversal, or just a random wobble in an ancient system that never stays still for long? In laboratories, supercomputers simulate the flow of molten metal 2,900 kilometers beneath us. The models show chaotic convection patterns, heat differences between core and mantle stir loops of current that can weaken, split, or merge the main dipole field. Most runs predict temporary multipole states, with several norths and souths scattered around the globe before the magnetic lines settle again. These transitions don't rip continents apart. They simply scramble navigation and allow higher radiation at the surface. Compared to Thomas's planetary slippage, that's inconvenience, not apocalypse. Still, the word inconvenience undersells the modern stakes. The magnetic field is our shield against charged solar particles. If it weakens significantly, satellites suffer. Power grids experience geomagnetically induced currents that can fry transformers. High-altitude flights take greater radiation doses. Migratory species, birds, whales, even some bacteria, navigate through magnetic cues that could distort. Civilization wouldn't vanish, but technology-heavy society would face weeks or months of costly chaos. That's enough reason for governments to model worst-case outcomes, whether or not they expect crustal collapse. The data for magnetic drift are public and precise. Since 1831, the magnetic North Pole has moved from Canada's Arctic coast towards Siberia. At first it crept a few kilometers per year. Now it races more than 40. The speed alone isn't alarming, it's happened before, but combined with overall field weakening, it hints at instability in the geodynamo. Instruments aboard satellites like Swarm and Arsted chart that motion daily, feeding global models used for aviation, mapping, and military navigation. Every 5 years, those maps are recalibrated because magnetic coordinates literally age out of accuracy. When soldiers, pilots, and missiles rely on those numbers, governments take magnetic turbulence seriously. And that's where myth and defense policy start to intersect. A crustal shift may be fantasy, yet a magnetic one is measurable fact with real operational consequences. A communication blackout caused by solar activity during low field conditions could mimic the first hours of a cyber attack. Missile guidance systems relying on magnetic headings could fail simultaneously worldwide. From a strategic perspective, that's not science fiction, it's vulnerability. It's easy to see how a century of pole position studies morphs into contingency planning. Military analysts chart geophysical risk corridors, where field intensity changes fastest, largely for navigation correction and satellite safety. Out of context, those maps resemble the disaster projections circulating online. Flood zones? Probably not. Magnetic uncertainty zones? Definitely. When data leak without explanation, people fill in the blanks with prophecy. For geologists, reversals are signs of a healthy, dynamic planet. The field's constant movement dissipates heat from the core and maintains the geodynamo. Without it, we'd lose atmosphere like Mars. But for the rest of us, hearing that north might soon become south triggers an ancient fear, that the ground beneath us isn't permanent. Scientists assure us the process unfolds over thousands of years and leaves oceans where they are. Yet deep down, we crave drama, and history provides it. The rock record proves reversal, myth supplies destruction. Together they make sensation. The real question is timing. Statistical patterns don't predict an exact schedule. Some intervals between reversals last a few thousand years, others stretch 20 million. We live within one of those long pauses. Could another reversal start tomorrow? Possible. Could it take another 500,000 years? Equally plausible. What makes the current moment feel unique is speed, field decay, pole acceleration, and anomalies all trending faster than we've measured in modern times. Whether that curve continues or stabilizes, nobody knows. When government scientists brief policymakers, they frame it carefully. No sign of impending catastrophe, growing uncertainties to monitor. But imagine condensing decades of such data into a classified report titled Geophysical Transition Forecast. Strip out jargon, add risk colors on continental maps, and you'd have the perfect seed for misunderstanding. A map that looks like prophecy but is really maintenance. So yes, Earth's magnetic poles can and will reverse. The evidence is undeniable and majestic. But unlike the sudden rotational slip of folklore, this transformation happens in slow motion, over scales of civilization itself. The danger lies not in the physics but in the perception, how we react when science speaks a language that sounds apocalyptic. That brings us back to secrecy. If governments quietly prepare for the technological consequences of magnetic instability, doing so under classified projects may look exactly like hiding doomsday knowledge. And that perception feeds the same loop John Thomas started. Mystery creating myth, myth creating fear, fear demanding secrecy again. In the next part of the story, we'll see how that loop formed during the Cold War, when agencies began folding planetary science into national security planning, and the idea of a magnetic disaster found its way into Pentagon vocabulary. Cold War fears and Pentagon interest. To understand how the idea of a pole shift moved from dusty library shelves into the deepest files of the Pentagon, we have to return to the environment that made secrecy the default language of science, the Cold War. In those decades, every new discovery, no matter how abstract, came with a single question attached. Could this become a weapon or reveal a weakness? It didn't matter whether the subject was particle physics, weather control, or planetary motion. If it might influence war or survival, it belonged behind locked doors. So picture the United States in the mid-196s. Satellites newly orbiting, nuclear stockpiles expanding, and continental defense planners drawing up survival blueprints for every imaginable nightmare. They modeled nuclear winters, asteroid impacts, pandemics, and even sudden geophysical disasters. The goal wasn't academic curiosity, it was continuity of government. How do you preserve command if the surface itself becomes hostile? Within that atmosphere, Hapgood's and Thomas's ideas slipped naturally into discussion. The phrase Earth crust displacement appeared in the same breath as planetary resilience. To a strategist, both posed the same logistical puzzle: relocation, communication, reconstruction. If Earth could theoretically shift its outer shell, even if the odds were 1 in a million, the military wanted a file on it. The newly formed Defense Civil Preparedness Agency kept shelves of low probability, total impact scenarios. Sources from the era mention global destabilization models, a phrase broad enough to cover nuclear and natural catastrophe alike. Funding for studies followed an unusual path, through defense-related universities and think tanks that specialized in systems analysis. Rand, MITRE, and the Lincoln Laboratory all hosted research on atmospheric and magnetic phenomena, officially tied to missile navigation. Yet buried in progress memos are references to geomagnetic anomalies and polar drift compensation. The context was guidance systems, but documents often strayed into speculation about large-scale magnetic variation and its long-term consequences. Whether that curiosity led anyone to evaluate pole shift hypotheses directly is uncertain, though later CIA files indicate at least peripheral awareness. Then there were the underground complexes, literal layers of secrecy built into mountainsides. As superpower tensions rose, U.S. agencies designed bunkers like NORAD's Cheyenne Mountain to withstand nuclear assault and natural upheaval alike. Internal memos from the 197s classified these spaces under continuity of operations plans, referencing not just blast tolerance but geophysical integrity. It's bureaucratic phrasing, but some historians believe it includes contingencies for earthquakes, crustal stress, and mass landform change. In simple terms, if the planet shakes, command must still function. To an outsider decades later, that language sounds hauntingly similar to Thomas's descriptions of continental catastrophe. The crossover between catastrophe theory and military engineering wasn't unique to America. The Soviet Union ran its own studies under geophysical warfare programs, investigating whether nuclear detonations could trigger seismic or atmospheric disturbances. Western analysts read those reports with alarm, sparking reciprocal research to understand any natural instability, that could be weaponized or blamed during crisis. By the late 197s, phrases like geodynamic response modeling appeared in NATO technical glossaries. Most of it focused on earthquake prediction, but once again, the vocabulary overlapped with the lexicon of speculative catastrophism. It's easy to see how those coincidences hardened into legend. When obscure scientific terms surface in defense budgets, curiosity explodes. In 1981, a declassified memo from the Federal Emergency Management Agency mentioned national relocation contingencies in the event of continental reconfiguration. The phrase almost certainly referred to nuclear fallout zones, but the wording fueled rumor that someone inside FEMA was quietly preparing for a physical shift of the continents. Archivists would later show that the continental reconfiguration map attached was a simple thermal blast outline, but imagination rarely waits for context. Meanwhile, the era's fascination with planetary threat deepened through public propaganda. Films, government pamphlets, even classroom drills taught citizens to seek shelter from radiation or environmental collapse. Those same years saw NASA's planetary defense initiatives quietly coordinate with the Department of Defense over asteroid detection. Outwardly, it looked like space science. Inwardly, it was survival strategy. To planners conditioned by worst-case logic, the difference between an asteroid impact and a pole shift was scale, not category. Both could end civilization overnight. During the late Cold War, the phrase global cataclysm scenarios appeared repeatedly within Defense Advanced Research Projects Agency archives, linked to environmental monitoring satellites. Officially, these networks tracked weather for military logistics. Unofficially, they fed data into simulations exploring how atmospheric or magnetic disturbances could impact weapon guidance, communication, and early warning systems. Those simulations required comprehensive topographic inputs, the same kind of data later seen in the leaked Pentagon map. Whether coincidence or inheritance, the resemblance is uncanny. Rumors of CIA involvement with unorthodox geoscience peaked in the 197s when reports surfaced about Project Stargate's psychic experiments. Though unrelated to geology, that program reinforced the image of intelligence agencies chasing esoteric knowledge. Against that backdrop, the classification of the atom and Eve's story seemed less bizarre. If analysts were probing extrasensory perception, why not evaluate catastrophic Earth physics too? Declassification requests decades later confirmed the agency had indeed filed the book, but disclosed nothing about internal commentary, only that it was stored under Earth science assessments.